Alright, so for the practice test, which I am having you work through today on your own, work with a little bit with a group, and then come back and listen to this, you need to know the following things. Number one, I'm going to give you the unit circle, okay? So when it says find the exact value, you need to do these from the unit circle, okay? I don't want decimal answers here, so please, for the love of everything that you need to do here, don't use your calculator, okay? You can plug it in to check if you want, but for this one, cosecant, what I remember here is that, maybe it helps to write this, that secant is 1 over cosine, that cosecant is 1 over sine, and that cotangent is 1 over tangent. Okay, so, or cotangent is also x over y, if you want to think of it that way. Okay, why is that important? Because I want to realize what values I'm looking at on my unit circle. Remember that cosine is your x values and that sine is your y values. And if you remember that, as you go through this, this becomes fairly simple. For cosecant 30, cosecant is 1 over sine. So, I need to find the sine value at 30, which is 1/2. And then because these are reciprocal functions, I just flip it upside down. 2 over 1. That reduces to 2. Done. Cotangent of 30 is the x value at that point over the y value at that point. And the x value at 30 is the square root of 3 over 2. The y value at 30, we just did that, is 1/2. And when I divide fractions, remember, that's keep it, change it, flip it. Multiply fractions across, 2 square roots of 3 over 2, those cancel, and square root of 3 is your answer. Secant of 135. Go to 135 on your unit circle. You'll see it's negative square root of 2 over 2 is the cosine value because it's secant. So I just flip it. 2 over square root of 2, and I'm just going to put the negative sign here. It doesn't matter if I put it on top or on bottom. You should recognize that I can't have this in the denominator, so I do that square root of 2 over square root of 2 thing, and I get 2 square roots of 2 over the square root of 4, which is 2. Those cancel, and the answer is simply negative square root of 2. Okay, don't forget about that negative sign. Cotangent of 180, again, is x over y at that point. The x value at negative 180, or at 180, excuse me, is negative 1. The y value is 0. Can't divide by 0. That's undefined. Cosecant of 90 is 1 over the sine value at 90, right? So the sine value at 90 is 1. 1 over 1 is just 1. Now, a lot of you are saying, but wait, can I just take the number and flip it? Yes. The sine value at 1 is 1 over 1. Flip it, it's 1 over 1. It's still 1. Same thing. Secant, I'm going to have the reciprocal of that cosine value at 180, and the cosine value at 180 is negative 1. So if I flip it, I can basically get negative 1 over 1, which is still negative 1. Cosecant at 120, I need the sine value, because the s is the middle none, the sine value of 120, which is square root of 3 over 2. So I flip it, 2 square roots of 3, 2 over square root of 3, excuse me. Can't have that, so I do this thing to the top and bottom, 2 square roots of 3 over 3, and that's as simplified as I can get it. Cotangent at 90, again, x over y at 90 degrees. The x value is 0, the y value is 1, which simplifies to give me 0. What I want you to notice is every answer on this is different. It's going to work a lot like that on the test as well, okay? Alright, let's keep going here. I've got these easy ones, because remember these are just reciprocal functions, so I just flip it. But you must reduce it, and I'm going to give you problems on the test. You must reduce as well. So I reduce a 2 out of both of those, and I get 10 over 7, and that's good enough. Don't have to write 1 3/7. This is 36 over negative 24. Reduce it. If you don't see that, well, 2 goes into it, so I'm going to divide them both by 2 to get 18 over 12. 6 can go into both of those, which is 3, so I'm going to divide by 6 here. 3 over 2, and the negative comes along, so negative 3/2 is my answer. From the very beginning, if you had saw 12 goes into both of those, you would have got to there in one step. Now, for the problems for 11 through 16, you're going to need your calculator. I'm going to let you have your calculator for this whole thing, but don't use it up here, okay? Now, For this, all this means is 1 over, we've talked about what is secant, 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent, and I'm going to say that this is 1 over sine of 175. It's degrees, and I have a little reminder here, you should be in radians or degrees. You need to determine that. I'm not going to tell you that. But on your test you should realize that if it's in degrees, my calculator better be in degrees. None of these here have degree signs. Those should be in radians. So in degrees, 1 over sine of 175 is 11.47. In degrees, 1 over tangent of 95 is negative 0.09. It says round to the nearest hundredth, which means 2 decimal places. This is 1 over cosine of 245. Plug it all right into your calculator, negative 2.37. So these should all be in degrees. Okay, let me keep going here. Now I don't see any degree signs on any of these, so these should all be in radians. Okay. Now, 1 over tangent of pi, which when you plug it in is going to say cannot divide 0, which is because tangent of pi is 0. And I can't divide anything by 0, so I get undefined. I don't even need you to show this step. When you plug this into your calculator, it's going to tell you undefined can't divide by 0. Just give me an undefined symbol. Good enough. Secant negative 1 is 1 over cosine of negative 1, which is 1.85. And this is 1 over sine of pi over 5, which is 1.70. Okay? Simple as that. Don't make those harder than what they are. Number 17, this kind of goes back to the most recent notes that we did on Friday, is I'm going to draw a flagpole, because that's what it's telling me, and I'm going to make a triangle out of it. I know the flagpole is created at a 90-degree angle. It says the angle of elevation with the sun is 55 degrees. So angle of elevation starts from a horizontal line looking up, not here. It's not going to be there on the test either. Okay, let me move this up so you can see what I'm talking about a little better. Angle of elevation from a horizontal line looking up. The shadow was 210, so we're not going to label it here. This is where the shadow would be, 210. How tall is the flagpole? There's my x. Opposite over adjacent is tangent. Opposite over adjacent. Plug it in, and it's going to come out to be about 300 feet. I didn't tell you what to round to, so I think it's nice and easy if you just round to the nearest whole number, and that is correct. Now the next one says, what's the length of the shadow when the angle of elevation is 34 degrees? So we're going to place 34 here. I already know this is fixed at 300. It wants me to know that. So let's redraw the picture. This is 300. This is x. And this is now telling me it's 34. I'm still going to use tangent of 34 equals, now 300 for opposite over adjacent. And again, on this one, I went 210 times tangent 55, because when the letter's up high, you multiply. Right here, the letter is not up high, so I'm going to just switch places with these two functions. Divide that out, and I get 444.64 feet. That's it for this page. Let's go on to the next page. Okay, now for these simplified problems, remember I told you I'm not going to give you a verified one. All you got to do is use the functions, and I'm going to give them to you on the board to replace. And remember, anytime you see cosine or sine, it's just over 1. So this is cosine over 1 times sine over cosine. And we talked about cross-canceling, the things that can be cross-canceled, and I literally just get sine of theta. Now again, if you're using x here, that's what we've been doing over and over and over again, then you just say sine of x. And you know what? I'm going to do that on all these problems, so that they're all similar in terms of what I'm doing. So this is 1 over sine of x. Cosine again just goes over 1. Tangent, look right in your table, is this. Cross cancel, cross cancel, cross cancel. You get 1. Even if you don't see that these cancel, you would write sine over sine. You better know that that's 1. Okay. For number 20, I'm going to get cosine, and I could put that over 1, but I'm just going to see what happens on the bottom first here. Sine x over 1 times cotangent, which is cosine x over sine x. Cross cancel. Cosine over 1 is just that. I get cosine x over cosine x, which again is just 1. They cancel each other out. Okay? You're not going to get 0 on any of these problems, so please don't tell me that's 0. Next problem, sine. So I've got sine x over 1 plus cosine x over 1 times cosine x over sine x, which gives me sine of x over 1 plus cosine squared x over sine x. And we did some of these problems the other day. You need a common denominator, and your common denominator is sine x. This one already has it. This one, I need to make sure that I multiply the top and bottom by sine to get my common denominator. So that's going to give me sine squared x plus cosine squared x all over sine x, which is 1 over sine x. That was rule number 1. Sine x squared plus cosine squared x equals 1. And 1 over sine is cosecant x. Okay. Next problem, I'm going to go cosine x over 1 times 1 over cosine x minus cosine x over 1. So, let me distribute this. Again, tops times tops, bottoms times bottoms. I get cosine over cosine, which is 1, minus cosine times cosine is cosine squared over 1 is cosine squared, and 1 minus cosine squared is sine squared x. Playing off of that, cosine squared plus sine squared equals 1. For the next problem, again, I'm going to go cosine squared x over 1. I'm going to go 1 over cosine x. I'm going to go 1 over sine of x. I've got one cosine that will cancel out with one of my cosines here. And now what I'm left with on top is cosine x. What I'm left with on bottom is sine x, which you should recognize as cotangent x. Okay? Now, notice I'm not leaving any of these answers as fractions. 1 over sine x is not the answer. The answer is cosecant x. Okay? Let's go on to 24. 1 plus tangent squared x. Right in your work, on your worksheet, it says that that equals secant squared x, which is cosine x over 1 times 1 over cosine squared x. Take one out of there, take one out of there. 1 over cosine x is secant x. Okay. Next problem, this again can be replaced with sine. So I'm going to write this as 1 over sine squared x times sine squared x over 1. And again, I can cross cancel here, and I just get 1. Last problem, probably a little more troubling. It's a lot more like 21 than you think. I get cosine x over 1 plus sine x over 1 times sine x over cosine x, which again leads me to cosine x over 1 plus sine squared x over cosine x. And to be able to add fractions, I need a common denominator, which is going to be cosine x. And I'm going to kind of go more in depth on this one than I did the previous one. To get cosine x on bottom, I got to multiply the top and bottom by cosine x. So that's how I get cosine squared x. Now that I have a common denominator, I can just add my tops. Cosine squared x plus sine squared x, and that should trigger right away as being 1, and 1 over cosine x is secant x. And that is the answer for that one. Okay. Let's go down to the bottom here, and these problems are just like in that section we just got done with as well. What we're going to do is create a right triangle. I'm going to do it in both of these. Right triangle. It's telling me ABC is the triangle and C is the right angle. So I'm going to put C as my right angle. It doesn't matter where A and B are. I'm just going to put them here. You could flip them, doesn't matter. Across from big B is little b. So 5 goes here. Across from big C is little c. 10 goes there. Across from big A is little a. 5 goes here. Across from big B is little b. 6 goes here. And the first thing you got to do is find the remaining side, because it wants me to find that, and the other two angles. So the remaining side, I can use Pythagorean Theorem. A squared plus B squared equals C squared. A is the one I'm trying to find. B was 5. C was 10. Same thing over here. I'm going to do it all over again. Equals C squared. I get 5 squared plus 6 squared equals C squared. Do the math here. A squared plus 25 equals 100. Minus 25 to both sides, which is going to be different from what I do over here. A squared equals 75, and square root it to get A equals 8.7. Okay. Now, for the next problem, angle of A, you know what, let's just finish this over here too. 25 plus 36 equals c squared. Now I'm going to combine those terms and then square root it, and I get 7.8. Okay? Now, for the angles, I'm just going to use SOHCAHTOA. I know this is 8.7, but I'm not going to use that. If I find angle B, then I can just go 90 minus that to find angle A. Angle B, opposite over hypotenuse means sine. Sine of B equals 5 over 10. And to find the angle, I use the arc thing. So B equals the arc sine of 5 over 10, which is 1/2, by the way. And what I get is, well, it actually works out kind of nice. It comes out to exactly 30 degrees. Well, then this one has to be 60 degrees because 90 minus 30 would give me that one. Okay? Same kind of rationale on this one. But now from B, I've got opposite over adjacent. So I'm going to take tangent of B, excuse me, equals opposite over adjacent, 6 over 5. And I'm going to arctan both sides. So B is the arctan of 6/5. Plug it into your calculator. You get 50.2 degrees. And angle A then would be 90 minus that, which is 39.8 degrees. And that, ladies and gentlemen, is the entire thing. It took me, along with teaching it, while I go, 16.5 minutes to just do that. So, on test day, so on practice test day, I'm going to have kind of it set up specifically. And I'm not going to be here that afternoon. So we are going to use all this to your advantage. On test day, I'm going to go over it for 5-10 minutes, that's it, and the rest of the time you're going to be testing. So make sure you study this, work through it more than once if you need to. See you on Monday. Or see you tomorrow, excuse me.